Alrighty, howdy folks. So we will look at section 10.1. So move on to chapter 10, which is parametric equations. Let me start with the definition. A parametric curve in two dimensions is given by x equals f of t, y equals g of t, a less than or equal to t less than or equal to b. That's the whole idea is up until now, we looked at graphs of y equals f of x or x equals f of y, right? And y equals f of x, that curve is something that passes a vertical line test, whereas x equals f of y passes a horizontal line test. What if you were to have a two-dimensional curve which passes neither the vertical line test nor the horizontal test? Like imagine uh, a circle. Yeah, a simple circle should be good enough. You cannot actually write a circle as y equals some f of x, nor can you write it as x equals f of y. However, by using these parametric equations, we can define even a circle. Okay? And let me give you an example. Suppose we have x equals e to the t and y equals e to the negative 2t, and the parameter t varies from -1 to 2. Well, the truth is, the one way to draw this is to draw this curve is figure out a whole bunch of points. That means you make a table with the t in the first column, x in the second column, y in the third column. And you give a value of t to be -1 because you need to vary it from -1 to 2. Start with a -1 for t and figure out what x would be and then what y would be. So you will get 1 point in that curve. Now maybe change this t to negative 0.9. Just reduce it just a little, right? 0.9. At negative 0.9, figure out the same thing. What would x values and y value, what x and y values would be? Plot that point. So figure out a whole series of points, a sequence of points, and then plot them. And that's how you get the curve. Right? That's precisely what you did when you were in high school or in middle school. Boys and girls, do you know how the graph of y equals x plus 2 would be? Well, so you just simply make two columns, x and y, and change the values of x, figure out the corresponding y values, and plot those points. Right? That's what you do. Here you do the same, something similar. You can do something similar. But obviously, yeah, that's a painful process. So, um, push comes to shove, that's what you would do. But now that we have softwares available, I'm going to use a software. All right, method one is using what's called GeoGebra. You can download a free version of GeoGebra, and I like the Classic 5 edition. So download that one, and you'd be able to go through a sequence of steps and be able to draw this curve effortlessly. Cool. Uh, the first step would be, because x equals e to the t, we'll input in the input box. I'll show you all of this in GeoGebra. F of x equals e to the x. Because we want e to the t, we will start with f of x equals e to the x. Okay. And then we will, step 2, let's type g of x equals e to the negative 2x. Again, notice we are guided by what y is. Y is e to the negative 2t. So let's start with this. And in the third step, we type this thing. A is the name of our curve, just as f of x is the name of our function, or the curve of f of f. A is our curve, and we say f of t, g of t, comma -1, comma 2. What does this inform GeoGebra? it informs GeoGebra that you have to have for the x coordinate f of t. What is f of t? Well, because we entered f of x to be e to the x, the moment you say f of t, GeoGebra has got the smarts to figure out you mean e to the t. Isn't that what our x should be? E to the t? That's the idea. Similarly, g of x being e to the negative 2x means g of t would be e to the negative 2t as desired. And this t represents that, hey, our parameter that we are going to use is t. So that's why we said f of t and g of t to indicate that t is our parameter. And these obviously, these values -1 and 2 indicate the interval. -1 t ranges from -1 to 2. So that's what we do. If we do this, we get the curve. Isn't that a piece of cake? Let me demonstrate that to you. Those are precisely the steps that I will type. Okay, here f of x equals e to the x. Ta-da! There's the graph of that. G of x equals e to the let me put that in parenthesis, -2x. We got the graph of g of x. Then a equals, just as I said, curve f of t comma g of t comma t comma -1 comma 2. And there's our curve. All right. So we are seeing the f of x curve and the g of x curve, right? And we don't want those. So you can click on this, and this serves like a toggle for the visibility. Toggle switch. You can switch it on or you can switch it off. And we don't want to show the label. This is the curve, right? And to zoom in, you can put the cursor somewhere, and then if you have a mouse, scroll up, you can zoom. Simple. That's all there is to it. And now let's say we want to change the curve a little. I don't know. F of x is square root of 1 plus t. F of t is square root of 1 plus t. Well, if you double click on this, it lets you change right there. I'm going to delete this and make it into square root sqrt of 1 plus t. Come on. Square root of 1 plus x, I should say. And g of x to be square root of 1 minus g of x would be square root of 1 minus x, let us say. That is g of t is square root of 1 minus t. So to be able to change something like that, you can do this. You see my tendency to type a \sqrt. That's because I have been typing in what's called LaTeX, all your notes and stuff like that. And there, to represent a square root, you have to type \sqrt. Okay, and check this out. If we do that, we get a new parametric curve, which looks like it's just nothing but a quadrant of a circle, right? This is it, folks. So whatever you want, you can keep typing that one, and let me show you some interesting curves. I did the same thing, and ta-da! All right. We can do animation in the sense, That's okay. See, this is the graph of x equals t plus sine of 5t and y is t plus sine of 6t. So that curve looks like that. Isn't that fascinating? And so 0 to what? 3 pi, yeah? It looks like I went from 0 to 4 pi. Yeah, 0 to 4 pi. So that's a graph that looks like that. Let me show another one. Isn't that nice? This is the graph of x equals sine of 9t and y equals sine of 10t. And if we go from negative pi to positive pi, yeah? Dang, negative pi to positive pi will produce this curve. Okay, there's something else I have done. You can do animation. And let me turn the visibility off and produce a point. See this? So that's basically figuring out the different values of this parameter t1 um, that and plotting those points. So you eventually get the same curve, but this is actually a sequence of points as opposed to one nice smooth continuous curve. That's the only difference. Cool, you can play around and have fun. Uh, Try to produce a whole bunch of curves that you see in the textbook. So they have given you a lot of parametric curves that you're expected to produce. See if you can produce them. Cool. Am I done? Let's go. Oh, okay, that's done. It's the same curve. All right, folks, that completes. Oh, no, there's something else. Oops, sorry about that. What did, for instance, if you want to, yeah, if you want to change, yeah, maybe I'll quickly go over that stuff also. Um, if you want to change the interval on t, just double click on A in the algebra window and change the numbers. A curve satisfying the new interval is drawn. To draw completely, you just change. That's what I showed you. Okay, anyway, let's move on, folks. What was that second method? I said there are two methods. Well, sometimes, not always, sometimes it is possible to represent this parametric curve as some y equals f of x. Okay, how can we do that? Check this out. X equals e to the t, and so y is e to the negative 2t, right? So because x is e to the t, what if I try to write this y in terms of e to the t, as in e to the t, the quantity raised to negative 2? Then I can replace the e to the t with an x, so we get x to the negative 2, which is nothing but 1 over x squared. So y equals 1 over x squared is the graph that we actually drew there, but in a parametric way. That's the only difference. So this is the familiar hyperbola on the interval e to the negative 1 to e squared. What? Yeah, notice t went from negative 1 to to positive 2, right? So when you plug t equals negative 1, x equals e to the negative 1. That's what I got. And when t equals 2, x equals e to the 2. That is what I have here. That's all there is. Cool. That's it, folks.